Chapter 7, Section 3, Part 2. Binomial radical expressions is still the name of the section of the chapter. And this time we're going to talk about the conjugate. Conjugate is an expression where you change the sign. In the middle. So if I look here, this says conjugate, right? So I have an expression, 3x plus 1. I'm going to change the sign in the middle from plus to minus. And this would be the conjugate. So the 3x stays the same, the 1 stays the same. The only thing that's changing here is the sign. So a conjugate is an expression where you change the sign in the middle. Of two terms. Of another expression. And we need to know how to get the conjugate, because in order to get a radical out of the denominator, we have to multiply by the conjugate over itself. So it's going to be really important that you know how to write a conjugate. You will use the conjugate to rationalize a denominator with a radical binomial. Okay, we're going to use conjugate to rationalize the denominator with a radical binomial because it will get rid of any radicals. And that's the only thing that's going to help us get rid of any radicals in the denominator. So if we look at example 1, I've got 5 divided by 2 times the square root of 3 minus 4. Folks, this is a quantity. We can't just multiply by the square root of 3 over itself to get rid of the radical in the denominator. All right, so we have to identify what the conjugate is. Okay, so here, the conjugate of 2 root 3 minus 4 is 2 root 3 plus 4. Okay, then we're going to have to distribute in the numerator, and we'll have to FOIL in the denominator. See, because we have to take this expression, 5 divided by 2 root 3 minus 4, and multiply by the conjugate over itself. Remember, we're tricking the expression and multiplying it by what we say is a clever form of the number 1, right? Because any number multiplied by 1 equals that same number. So if I'm setting up my work, I've got 5 divided by 2 root 3 minus 4. The only way I'm going to get rid of and have no middle terms that involve a radical is to multiply it by the conjugate, 2 root 3 plus 4. But if I do that in the denominator, I have to multiply by that same thing in the numerator, right? Because 2 root 3 plus 4, which is a quantity, divided by itself is 1. And this number times 1 is this number. So it still keeps it equal. It's just going to make it look different. So in the numerator, we say we're going to have to distribute, and in the denominator, we have to FOIL. So I'm going to hold off on distributive property in the numerator for right now. I'm just going to write it as 5 times the quantity, 2 root 3 plus 4. But I'm going to FOIL right away in the denominator. Now remember, 2 times 2 is 4. Root 3 times root 3 is 9. So this becomes 4 times the square root of 9. All right, when I multiply these two, the outers, I get 8 times the square root of 3. So that's plus 8 root 3. And when I multiply these two, the inner, I get minus 8 root 3. And when I multiply the ends, I get negative 16. Now, notice what happens here. These are opposites, and they always will be. They will sum to 0. And notice the first guy and the last guy, they don't have a radical. Well, this does, but look, root 9 is a square. So it's going to come out. So what do I have? In the top, I have 5 times 2 times square root of 3 plus 4 over, this number is really 12 incognito, yes? 12 minus 16. I'm going to go over here. 12 subtract 16 is negative 4. Because that negative 4 doesn't divide this 5, I'm going to now distribute. So I've got here 10 root 3 plus 20 over negative 4. And you might think you're done, but folks, that's even, that's even, that's even. They're all outside of a radical. I do have to simplify this down. These can all be divided by 2. So this divided by 2 is 5, this divided by 2 is 10, this divided by 2 is negative 2. So my final answer to this problem is 5 square roots of 3 plus 10 divided by negative 2. You can't divide that and say it's 5 root 3 minus 5. Don't do that, right? Because this is a quantity. It means both of these have to be divided by negative 2. So don't make it disappear. Okay? Again, don't try to divide the negative 2 into the 10 because this is a quantity. Okay? Negative 2 has to be divided into that and that. Or you find the quantity first. After you find that value, then you divide by negative 2. So don't divide this out just because it divides into the 10. Unless you break it apart into 2 fractions. All right? Now, notice over here, we're saying that a plus bi, the conjugate of it is a minus bi. And then the conjugate of a minus bi is a plus bi. That's what that diagram is illustrating to you there. All right, this next problem, we have to figure out the conjugate because we have a radical in the denominator, but it's not just a radical by itself, it's a binomial. So the conjugate is 1 minus root 3. So now we're going to take this expression and we're going to write it as 4 minus the square root of 3, that quantity, over 1 plus the square root of 3, that quantity, times, here's my clever form of the number 1, then I'm going to multiply this expression by, to get rid of the radical in the denominator, 1 subtract the square root of 3 over itself. And now this time you will have to FOIL in both the numerator and the denominator. You see, before we didn't have 2 binomials in the numerator, right? We just had a constant times this binomial. But now we have 2 binomials in the numerator. So why don't you pause the video and see what you could do with this one, with all your simplifying and such. Okay, hopefully you pause the video and try this one on your own. When you FOIL the numerator, you should get 4 minus 4 root 3 minus root 3 plus root 9. Now remember, root 9 is actually equivalent to 3. Now, you know, if you just wrote this out and then you wrote this out, don't try to divide out those root 9s. You can't do that. You have to combine everything in the top first. That's a quantity, remember. Okay, and again here, this root 9 is going to turn into a 3. I have it written right here. All right, so I'm going to combine these like terms. So I've got 4 square root of 3, square root of 3, negative 4 minus 1 of those is minus 5 square roots of 3 plus 3, right? This root 9 is that 3. In the denominator, minus root 3 plus root 3, right? That's going to sum to 0. They're always going to go away and sum to 0. If you did it right, if you don't do it correctly, then they're not going to go away. And then your denominator will not be rationalized. Okay, so the middles should always be opposites and go away. And now I have 1 subtract the square root of 9, which is really 1 minus 3, right? Because root 9 is 3. And now the only thing left to do is to combine the 4 and the 3 to get 7. This is minus 5 root 3. Notice these have no common factors, and they're both odd, so it's not going to be divisible by my denominator, 1 minus 3 and negative 2. Final answer. Okay, so if you have any questions, please reach out so that I may help you. And make sure, don't skip these assignments because you're going to be lost if you do. And you need this to move on to the next level, like pre-calc and any other kind of higher math. Okay, let me know if you have questions. Have a great day.